When we pass a reference into a function, it's important to have a picture of what's going on in memory. So let's trace through this example and see what happens. So we have a function called foo, and it is getting a list of values as its first input, and then a single integer as its second input. And then we have some code down here that is going to use that function. And as we trace through, we're going to have three memory diagrams. One for before the function gets called, one for during the function call, and one for after. So we start out by having a stack frame for the global scope, and we start running the program. We define the function. We then assign 0 to the global I. We assign a reference to the list containing the values 1, 1, 1 to the variable L1. And again, it's important to picture this as a reference because lists are mutable. And then this next assignment copies what's in the variable L1 into the variable L2. And because what's really in L1 is a reference, we're copying that reference. So both L1 and L2 point to the same list. Then we make the function call. That gives us a new stack frame for the function itself. And we're going to pass in the inputs. And you can see we're passing in L2 for vals, and we're passing in the global I for the local I. And so down here, when we look at the stack frame, vals gets a copy of what's in L2. And again, that's a copy of the reference to the list, not a copy of the list itself. And I gets a copy of the global I. We then jump to the function and we start executing it. The local I gets changed from 0 to 1 using the plus equals operator. And then we come to this line. And this line says, go to position 1 in the list referred to by vals and double the value. So we follow the reference in vals and position 1 gets doubled. And notice that change is in the one and only one list that we have. So even after the function returns, which it does now, and its stack frame goes away, that change is still there in the internals of the list. And so when we go to print I, L1, L2, the global I has not been changed, but the contents of the list at position 1 have been changed. And notice I see that whether I use L1 or L2 because both L1 and L2 are referring to the same list. Now let's take our foo function and change this line. Instead of modifying what's in position I of the list, let's actually make the list variable refer to a new list. So now when we trace through, and by the way, let's change the name of this function to foo2. Now when we trace through, the beginning of the program is the same as before. We're then passing in L2 and I as before, and so the contents of the stack frame are the same as they were at the beginning of the original foo. But now, after changing the local I to 1, I'm now coming to this line, and I'm no longer changing what's in the original list. Rather, I'm creating a new list containing the values 1 to 1, and I'm assigning its memory address to the variable vals. So vals is no longer pointing to the original list. It's now pointing to the new list. And so now, when the function returns, which it does at this point, the stack frame goes away, as does the new list, because we don't have any remaining references to it. L2 and L1 are still referring to the original list. And that original list, its internals were never changed. And therefore, when we print, we're seeing the original value of I, and we're seeing the original list twice, once for L1, once for L2. So if we compare these two programs, the key difference was foo was changing what was in the internals of the list. And when a function does that, those changes are still going to be there after the function returns. If you pass in a list to a function and that function changes the internals of the list, those changes will still be there after the function returns. However, this function, foo2, wasn't changing the internals of the list that had been passed in. Rather, it created a brand new list and changed what was in the local variable vals. So we're changing the local variable here and making it refer to something else rather than changing what was in the original list.